DS213 is a digital storage oscilloscope, small and portable. Its characteristics are it has two analog inputs, two analog channels, and two digital channels here. The maximum sampling rate is 100 megasamples per second. Just remember the sample rate is how many measurements are taken per second, and it has a 15 megahertz analog bandwidth. The bandwidth is the maximum frequency of an input signal which can be scanned with minimal amplitude loss. Anyway, I usually recommend at least 10 to 20, 30 samples per cycle. The maximum input voltage is 40 volts peak. It includes a waveform generator through this output, and the screen is 3 inches with a resolution of 400 by 240 pixels. Here you have the USB. The USB is for charging the batteries, downloading files, and firmware update. And here you have the power switch. Okay, the 4 inputs are ports MCX using MCX connector, so are like this one. But if you are going to use the normal BNC connectors, you have this kind of converter, so you could use like this one, connect it, and that's all. Okay, let's switch on it. And the first thing that you see are several lines. Okay, so let's see what we have in the screen. The first thing I want to show you is the grid. I don't know if you could notice that. Okay, there are lines. Okay, it's a grid. Okay, that grid will help to measure time and voltage. Okay, you have these 4 lines. Okay, well, there are 2 overlapped. The first one, let me move this one up so you could see it better. Okay, you have A in blue is channel A, B in yellow channel B, channel C in purple, and channel D in green. Okay, these 2 channels are analog and these 2 are digital. Okay, also you could see here a line in the middle. This one is the trigger point, the trigger level. Okay, and this is the 0 time. Okay, you could see you have many things around, and you could move around all this using these buttons. So let me explain you about these buttons. These buttons at the top are called K1, K2, K3, and K4. Okay, so I will refer like that. And you could see at the top of the screen what each of the keys does. But just this is a round pause, so when it is running, scanning, if you click it, pause. Okay, this one goes to display menu. That is a general menu that you could see have different options. These are for saving and loading files. This is to save that file, to load that file. We will see later for what purpose. Save the buffer and save CSV format that you could read in Excel, for example. The volume, you could set the volume of when you push the buttons. The LCD backlight, you could reduce it or increase to see it better, or save some battery, and the amount of time before it powers down, 5 minutes by default. And K3 to confirm. So if you are going to save something, just K3, so 1, 2, 3 to save, and you see, okay, completed. Okay, the next one is this one, the K3. This helps to switch between channels. We will see later. And okay, we click here, so the menu disappears. And this one is a FN combination key. So if you hold it and move the encoders, they will move faster. I will see the encoder for what purpose. if you click here and here at the same time, it takes a snapshot, save image, okay? If you click here and click here, you save the system settings. And if you click here and here at the same time, you go into auto calibration, okay? Then we have the wheel A and wheel B, also called encoders. Wheel A is to adjust and or change an option. For example, we have here YP is to move this in the y-axis, so you see it is changing, and this one B, the B wheel, is to move through the different options. You see it's blinking and going to other options. Okay, so that's all. Okay, let's go now to the parameters area that is at the top. Okay, you could see here in the parameters area that you could access to different things. In order to see that properly, I will connect this one so we could see a waveform. Okay, we have a waveform, and first thing we have to change the frequency, okay, and the trigger. Okay, that's all. Okay, so let's go here, and what we have first of all is that this one is the battery, this one is to the status, so it is running or stop. If you click here, hold. Okay, this one is channel A, channel B, channel C, and channel D. Channel A, this is a coupling, so you could go to the coupling and change that between DC AC or disable the channel. Okay, and you could change the voltage, the amplitude, so it is this is the distance between the two consecutive lines of the grid. Okay, so from here to here you have 1 volt, so you could increase or decrease. If you increase, it reduces it. If you decrease, okay, it start blinking because the trigger line is out of the function. Okay, you have to put the trigger line in the middle of the function, otherwise it will not stop. Okay, so we have this one. Then we could go to other channel. Let's say we connect just something in the second channel. Okay, and we have a square function there. Okay, let's see what we could do. The first thing is that we could change the value, as I mentioned, DC, and let's say, okay, I could put it, I will put it in 2 volts, and okay. Then what you could do is channel C. Channel C could do several things, or just show what is going through the channel C, or do calculation between channels A or channels B, or do operational Boolean operations between channel C and the inputs. So if you change this, you just get A plus B. You see the purple one is A plus B or A minus B. You could move these functions. Okay, we will see later how. C plus D, C and D are Boolean operation. There is nothing in C and D, so or do anything else. Okay, let's see, for example, that I put just channel C, and I will take this one as it is a digital input. I will put it here. Okay, and I will put another digital signal here. Okay, so we have these two. Now I could go to C, you see, and I could say, okay, I want operations between these two, but I will not see this anymore. Okay, so let's say that it is C and D. So this is the operation, the AND operation between this and this. So you get that one, C or D, inverse A, inverse V, and that's all. Okay. Next one, channel D. In channel D, you could have channel D, that is the green, or you could also do some operations, as you could see here, with saved information and a memory. So let's say that, for example, imagine that you go to the menu, okay, and you save in these 5, okay, so you just save, it is completed, and you come back, you go in channel D and say, okay, I want to show what is recorded in channel A. You do not see anything. But if you go to the menu again and you go to load, load, it was the 5th one, complete, and you have it there, okay? So this is what is recorded from channel A. You could then change channel A and do whatever you want, like change the function, and you see you have the previous one. So okay, let's continue. Next one is the X position. It is just the position, you see, of the functions that are recorded, are there scanned. Okay, more things. You go here and you have the trigger. So this one defines where the trigger is. So in the let's go to the trigger, is there. So if we move it, you see the blue line is going up or going down. This is for channel the channel A, but you could change channels. So you could say, okay, I don't want to trigger based on this channel, I want to trigger based on other channels. So for example, let's take this one and put it here. Okay, so, or instead of this one that is a squared one, it's okay, it's okay, this one. So I want to trigger, instead of based on this blue one, I want to trigger based on the yellow one. So you just click here and you change, it will change from blue to yellow, you see? So now this is the trigger, and you could have the line in a different position, okay? So you could have the trigger here, and if you come back, or you just change through the different channels to the one, you see the line there. So you could go like saying, okay, I'm going to trigger based on this channel, or based on this other, yellow, purple, green, okay? Next one is the edge. Okay, and as you could see at the top left of the screen, there are different kind of triggers. It's not only falling or rising, but also you could have the smaller than trigger, larger than trigger. So if something happened over that or below that, okay. If also you have a negative pulse with that is larger than the trigger, or positive pulse that is larger than the trigger, and so on. So you just could play with that, okay? But usually you use the falling or rising edge. Here you have the modes of the trigger. Usually you have it in auto, but you could have in normal, single. So it whenever it happens, the trigger condition, it will just hold and stop. You have to start again every time until the new condition happen. So it is good to just keep something that happen very rarely from time to time. Okay. Also you have this slow and auto. Okay, next one is, this is the time base. So is the distance in time between two vertical lines in the grid. Okay, so it is 200 microseconds from here to here. So from here to here you have 400 microseconds, and from here to here we will see later how to calculate that. Okay, so if you change that value, it will just let me see, it should, oh, okay, it's on hold. Okay, okay, so it should, okay, it should zoom or expand. Okay, you see. The next one is the function generator. You could generate a square function, a sinusoidal function, triangular, or sawtooth. You will not see the function here. You only see a representation of that there. All of the functions are 3 volts peak generated, and the square function, you could generate it between 10 kilohertz and 8 megahertz. And the triangular, you see sine, triangular, sawtooth, and if you go to the next one is the frequency. So you could go with the rest, the sinusoidal, triangular, and sawtooth between 10 hertz and 20 kilohertz. Okay, now I will jump to the bottom of the screen. So this area at the bottom of the screen, later I will explain what is this. These are measures. Okay, so what kind of measures we have there? Well, here we have measures about time, and here measures about voltage. So here measures about y-axis, and here measures about x-axis. So sorry, x and y. X-axis and y-axis. Time and voltage. Okay, what kind of values? Okay, let's go there. The first thing is that you could change, you want to measure something, so you could change. Now you are measuring the frequency of the yellow channel, so this the B channel. But if you change, you click here, you change the channel. Okay, so now is the channel C, channel D, channel A, again B, C, D, A. Okay, I will take this one because it has a different frequency, and I will put it here. Okay, and you see here that you have about 1 kilohertz in the blue one, and if you click here you have 3 kilohertz. Okay, is the frequency I'm generating from a function generator. Okay, so let's see what other values you could have here. Apart from frequency, you could have the duty, you could have I will explain this one later. These are different values, like this one is the high level time of a single cycle. This one is the low level time of single cycle, so the distance between here to here, it is 260, and this one is about 70 microseconds. And also you have this cycle, that is the signal cycle, and the frequency as before. So you could just go and do here the same, so you could change whatever for any function. So you could have different values of the same function or of different functions. Okay, so let's see this one that I mentioned before. You could have that in any of them. This is the increment of time. This is the distance between two markers. Time is this axis. So between T1 and T2, how we activate these markers? Okay, you could go here to T1. Okay, and if you want to see it, you just click this button, the key 3, and you see it. Okay, you see it? You could activate or deactivate. Okay, and then you go to this other one and you activate again. And now you have these two lines. So this is the distance between here and here. Okay, so you could say, okay, T2, I will move T2. So I just move T2 wherever I want. And for example here, and I go to T1, and move the one from, for example, here. So the distance between this and this one is 260 microseconds. Okay. Okay, let's see this other. These other are related to voltage. Okay, so you could have the same, but as this is related to voltage, this is only valid for the analog signals. So A and B, not C. Okay, because they are digital. Okay, so here you have these volts peak. You could have different values like volts or RMS. You could have volts average, and this increment in voltage we will see later, and the volts of the trigger, the volts of the battery, and the maximum voltage, minimum voltage. Okay, so what is this? This is the same as before. So is the distance between these two markers. So I go here, okay, and say, okay, activate V1. I see the line, and activate V2. Okay, you see the line, and I want to move V2, so I could measure, like for example, the distance between the bottom of the function and the top of the function. And I see that this is about 5 volts, more or less. Okay, so this is for that purpose. And in the last one, we could have also this, the same thing or different things in different functions. Okay, so that's all. It's a very nice oscilloscope, very handy, small, portable, so nice thing. Thanks for watching.